In this example, I would like to talk about oddities. In other words, knowing what it means when certain pieces of information fail to exist. You need to know that you're not doing the wrong thing and that some particular functions don't have some of the 8 steps that we've talked about. And so on this example, let's go and first find the domain. To find the domain, I know I need to set the denominator equal to 0. So I would say x squared plus 1 equals 0. Well, this is not going to factor because it's not the difference of squares, it's the sum of squares. So if I'm going to be able to solve this, I'd need to subtract the 1 over. So I'd have x squared equals negative 1. And then I would solve by taking roots. So square root of x squared. And then make sure to remember here, plus or minus square root of negative 1. Here, the root and the square cancel. That leaves me x. And then on the right side, I'd have square root of negative 1. Square root of negative 1 is I. So I end up with x equaling plus or minus I. Well, that's an imaginary kind of solution. So I'm going to say here this is a non-real result, and that's a problem. Okay? So on here, what we find out, if we try to set the denominator equal to 0, we don't have any real numbers that would give us a denominator of 0. What that means is that there's no numbers left out of the domain. If that's the case, then the domain is just negative infinity to infinity. So this is kind of a strange situation given the other examples that we have worked. The second thing, let's say we'd like to go and find the x-intercepts. Well, we know we find x-intercepts after we factor and cancel, and we find them from setting the numerator to 0. Well, the denominator of this particular problem doesn't factor. So nothing factoring in this case means certainly nothing cancels. So if I'm going to find the x-intercept, I set the numerator to 0. Well, this is not true. We have seen this before, okay, but this we know means that there are no x-intercepts. All right, step 3, finding the y-intercept. We know we're supposed to evaluate our function at 0. So f of 0 would equal 5 over 0 squared plus 1, which would be 5 over 1, which would just be 5. So we do end up having a y-intercept at 0, 5. Right? Fourth step, we'd make a note about holes. Okay, I know we've talked about holes. We haven't found any in the most recent problems, but we want to make sure to check for them. This example didn't factor, so naturally nothing canceled, and so there are no holes. All right, looking at step 5, we'd start talking about finding asymptotes. So asymptotes. Step 5, we look at vertical asymptotes. Okay. Vertical asymptotes are found by setting the denominator equal to 0 after you factor and cancel. Well, nothing factored and canceled, and setting the denominator equal to 0, we've done before. That was where we set x squared plus 1 equal to 0. And remember there what we got is we got non-real results. Well, if we got non-real results, that means that there were no vertical asymptotes. Sometimes it makes it awkward when we get a lot of answers that we have none. This makes it, I'm going to say, difficult to graph because we don't have the usual references that we have in other problems. All right, next thing, horizontal asymptotes. Well, horizontal asymptotes depends on the degrees of my original polynomial. So let's go back up and look. In the top, degree of the numerator is equal to 0 since there are no x values, and then degree of the denominator is equal to 2. Well, if degree of the denominator is larger than degree of the numerator, there's a horizontal asymptote automatically at y equals 0. So we'll make that note. Degree of denominator was larger than degree of numerator, so it's automatically meaning you have a horizontal asymptote at y equals 0. All right, number 7, oblique asymptotes. Well, Oblique asymptotes happen if the degree of the numerator is larger than the degree of the denominator. Okay, since we found a horizontal asymptote, we have no oblique asymptotes. So now it's time to try to graph my problem. So step 8 to graph. First thing I want to do is go back up and graph any kind of points that I got. Well, I didn't have an x-intercept. I did have a y-intercept of 0, 5, so we will graph that. And then we want to go and graph any kind of asymptotes we had. Didn't have any vertical asymptotes. We did have a horizontal asymptote at y 0. So I'll dot the x-axis and label that y 0. And that was all we had. Now, this being all we had forces us to go to our calculator. We know that the graph must show up above the x-axis because we have a y-intercept above it. But we don't necessarily know what the shape of our graph is going to be. So now, just go to your graphing calculator. Make sure that when you enter the equation in for y1, that you use parentheses around the numerator and denominator. So I'll open my calculator up and put that in to y1. So parentheses 5, close parentheses, divide by, open parentheses, x raised to the second, and then plus 1, and then close the parentheses off. It looks like a standard window would work. We know that this y-intercept would definitely be within that. Looks like I have a typo up here. This needs to be a plus 1 and then close parentheses. Alright, and then let's just graph this in a standard window. And there it is. So it looks like my y-intercept is actually kind of a relative maximum, and then my graph gets pulled towards this horizontal asymptote that I have. So it looks something like that. It may not be so sharp as I have it written. In other words, it may kind of more curve in, kind of like an upside down parabola, but it looks something along those lines as far as the shape. Okay, but without my calculator, I would have had a very hard time knowing that that's what the graph looked like.